What kind of things exist? A five-fold classification for understanding the universe. Welcome to this episode. In the previous episode, we asked how we can study what cannot be directly seen. We distinguished the sensible from the insensible. But that distinction immediately raises another question. Not everything unseen has the same status. Some unseen things are physical realities known through their effects. Some are theoretical constructs. Some are hypotheses awaiting confirmation. And some are propositions that evidence has rejected, or entities that belong to fiction rather than physical inquiry. So before we study the universe, perhaps we should ask a more fundamental question. What kind of things are we talking about? This episode develops a five-fold classification proposed in my manuscript. The purpose is not to create terminology for its own sake. The purpose is to keep observation, inference, theory, hypothesis, and fiction from being confused with one another. Part 1. Category 1. Sensible things. The first category is the simplest. Sensible things are physical things directly available to our senses. A rock. A tree. Water. A flame. We can see them. We can touch them. We can weigh them or otherwise interact with them directly. They form an important starting point for scientific inquiry. But there is a small qualification. Directly sensed does not mean infallible. Our senses have limitations. An object can appear smaller at a distance. A stick partly immersed in water can appear bent. A visual illusion can make us perceive something that is not actually there. So the word sensible should mean directly accessible to perception, not automatically true in every interpretation. The sensible gives us phenomena. Measurement and reasoning then refine our understanding of those phenomena. Part 2. Category 2. Instantaneous observable physical things. The second category moves beyond direct sensation. Some physical realities cannot be seen or touched directly, but can reveal themselves through a relatively immediate, characteristic interaction. Consider light. A photon is not something the naked eye sees as an individual object. But a photon can interact with matter. For example, photons can produce measurable effects in detectors, including the photoelectric effect. Electromagnetic radiation can also be detected through instruments designed to respond to it. Magnetism is another example of something that is not directly seen as a substance, yet produces observable interactions. The important point is that the physical entity is not established merely because we imagine it. It is connected to a measurable effect. However, known through a single effect should not be interpreted too literally. In real experimental science, confidence in a physical entity normally comes from reproducible measurements, controlled experiments, and consistency across different observations. The category is therefore best understood as a conceptual distinction. A physical phenomenon can sometimes reveal itself through a relatively direct, characteristic effect. Part 3. Category 3. Multifactorial observable physical things. Now we arrive at the category that is especially important for our study of locomotion. Some physical realities are not established through one simple observation. They emerge from a network of phenomena. Gravity is an example. We do not see gravity as an independent object. Instead, we observe falling bodies, planetary motion, tides, orbital behavior, and many other phenomena. We connect these observations and identify a consistent gravitational relationship. Momentum is similar. We cannot point to momentum as a visible object. But collisions, rebounds, trajectories, and changes in motion reveal regularities that can be described in terms of momentum. pressure impulse, in the framework developed in my work, is also placed in this category. Its proposed reality is inferred from the relationship between pressure-driven events, ejection, acquired velocity, and subsequent motion. This category therefore requires more than seeing. It requires reasoning across multiple effects. And this is precisely why such variables can be easy to misunderstand. The phenomenon is visible. The explanatory variable may not be. The variable is reached through a chain of observations and reasoning. Part 4. Why multifactorial variables matter. This distinction is particularly important in physics. Suppose we see a projectile moving through the air. The projectile is sensible. Its trajectory is observable. Its speed can be measured. But the concepts we use to describe its motion, force, momentum, impulse, acceleration, gravitational influence, are not all objects that can simply be held in the hand. They are explanatory physical quantities, or relationships inferred from measurable behavior. Therefore we must avoid a common mistake. If something is not directly visible, that does not make it imaginary. The proper question is, what phenomena support it? How consistently does it explain them? Can the relationship be measured? Can the proposed explanation make predictions? And can those predictions be tested? Part 5. Category 4. Non-substantial hypotheticals. The fourth category is much more difficult. Here we encounter concepts that may be proposed as explanations or models but whose status as physical entities is not established merely by the concept itself. Examples in the manuscript include the old ether concept and the multiverse. But this category needs especially careful wording. A theoretical construct is not automatically meaningless simply because it is not directly observable. Science often uses mathematical and theoretical entities that are not directly perceived. General relativity, for example, describes gravity through space-time geometry. Quantum theory uses mathematical structures that do not correspond simply to everyday sensible objects. Therefore the scientific question is not, can I see it? The question is, what does the theory assert, what does it predict, and what observable consequences can be tested? A model becomes scientifically important through its connection with phenomena. A hypothesis becomes stronger when it survives testing and produces successful predictions. So this category should be understood as a warning against treating every conceptual construct as though it were already an established physical substance. Part 6. Category 5. Non-existence. The fifth category concerns things that do not belong to physical reality. Some propositions have been experimentally or theoretically ruled out in their proposed form. The ether is a historical example of a physical medium, once proposed for the propagation of light, but abandoned after experimental and theoretical developments. Perpetual motion machines are another example. Proposed devices that conflict with established physical principles. Other examples belong to fiction or mythology rather than physics. Ghosts, mythical beings, and purely fictional entities are not physical variables merely because people can imagine or describe them. This category is important because imagination has no natural boundary. Human beings can invent an unlimited number of entities. But physics cannot investigate every imaginable entity. Scientific inquiry requires a connection to nature. Part 7. The five categories together. Let us now place the five categories side by side. Category 1. Sensible things. Physical, directly accessible through the senses. Rocks, trees, fire, water. Category 2. Instantaneously observable physical phenomena or entities. Physical, but known through relatively direct measurable interactions. Photons and electromagnetic radiation provide examples of the kind of phenomenon we mean. Category 3. Multifactorially observable physical realities. Physical, but established through many effects and sustained reasoning. Gravity and momentum are central examples in our framework. Category 4. Non-substantial hypotheticals. Conceptual or theoretical proposals, whose physical interpretation or independent reality must not be assumed merely from their existence as ideas. Category 5. Non-existence. Claims or entities that have been rejected by evidence, lie outside physical inquiry, or belong to fiction rather than nature. The categories therefore ask two different questions. What kind of reality are we discussing? And how do we know about it? Those questions must remain separate. Part 8. Why this matters for the universe. When we turn toward cosmology, the distinction becomes even more important. The farther we look into the universe, the more dependent our knowledge becomes upon indirect evidence. We receive light. We measure spectra. We observe trajectories. We detect radiation. We measure gravitational effects. We infer properties of objects that we cannot physically touch. Therefore, cosmology is necessarily an exercise in disciplined inference. The danger is not inference itself. Inference is essential. The danger is forgetting that an inference is an inference. A measurement is not the same thing as an interpretation. An interpretation is not automatically a physical entity. A mathematical model is not necessarily a substance. And a hypothesis is not a fact simply because it is elegant. This classification is intended to keep those levels distinct. Part 9. The variables of locomotion. Now we return to the purpose of our larger inquiry. If we study locomotion, what should we study? The body itself. The observed motion. And the physical variables that consistently account for the motion. In the framework developed in my work, gravity, momentum, and pressure impulse belong to the third category, multifactorially observable physical realities. They are not directly visible like a stone, but they are approached through repeated phenomena and reasoning. This is why the study of locomotion cannot stop with appearances. We must ask what variables are actually operating. And we must distinguish those variables from the theoretical language used to describe them. Closing. What kind of thing is IT? Perhaps the most useful question we can carry into every scientific inquiry is a very simple one. What kind of thing is this? Is it directly sensible? Is it a physical reality revealed through a characteristic effect? Is it a physical variable established through many interconnected phenomena? Is it a theoretical construct, whose physical interpretation remains to be tested? Or is it something that nature gives us no reason to regard as existing at all? The classification does not solve the problems of physics. It does something more preliminary. It tells us where to place a claim before we begin arguing about it. And that may be one of the most important disciplines in science. Do not confuse the thing with the description. Do not confuse the effect with the cause. Do not confuse an inference with an observation. Do not confuse a hypothesis with an established reality. And do not confuse imagination with nature. The universe is there. Our task is to learn how to ask questions of it without telling it in advance what it must contain. Thank you for listening. This is Sayed Mustanvali, author of The Universe and The Universe Univocally. In the next episodes, we can take each category one by one and examine the actual physical examples that belong or may belong to it. Until then, keep observing, keep questioning, and above all, keep the distinction between nature and our ideas about nature clear.